Welcome to In Layers, where we explore the people and technology behind artificial intelligence. I'm your host, Ron Green. We're back with our monthly Decoded episode, where we cover the most important news and announcements in AI. There's big news from Anthropic, Nvidia, OpenAI, the Max Planck Institute, Meta, and much more. To help me cover it all, I'm joined by three of my amazing Kung Fu AI colleagues. My co-founder and distinguished engineer, Dr. Zizi Tsai, VP of Engineering, Michael Wharton, and Director of Engineering, Reed Koch. All right, Michael, Zizi, Reed, welcome.
Glad to be
Thanks
here.
for having us.
Yeah, thanks.
All right, I'll jump in first. There was some really exciting news from Anthropic last week on model interpretability. They released two different research papers. I personally think these are instant classics, meaning the level of depth and the level of, I think, analysis here is unprecedented. You know, I've been doing this a long time, and just the amount of compute that they had to throw at these papers to have reasonable results is incredible, and it would have been impossible just 5 years ago. So what they did was, at a high level, they wanted to understand at a deeper level how these really big large language models operate. And I want to kind of break this down into like, why did they do this? How did they do this? And what did they discover? The why is probably pretty clear. As AI gets ever more powerful and integrated into our life, understanding how these damn things work is increasingly important. And, you know, like the human brain, it's kind of interesting that as their abilities increase, our ability to understand them diminishes, right? Like they become almost more of a black box. And so this work on interpretability will be fantastically helpful, I think, in the long run. And we'll talk about this later, but I think it's even going to run into things like making these models safer, because they focused on hallucinations and jailbreaks and things like that we'll get into. So how they did this is interesting too. I'm going to kind of pass over most of the technical aspects of this because it is fairly complicated. But in their papers, the paper that they released last year, they were using a sparse autoencoder. They've shifted to something they're calling a cross-layer transcoder. And this is a more complicated architecture. The only thing that I'm going to describe that I think is maybe a little technical is these transcoding layers are fed the residual connections at the different parts of these network layers, and there's one for every layer. And then they use this to essentially reduce the computational complexity that they need to deal with to identify what they call features. And these features are essentially things like concepts. So they could look at the model and, you know, put in some prompt, and the model might focus on a feature like the state of Texas. And that's an example we're going to look at. And they can tell when it's doing that, and they can tell what it's focusing on. And they, from a feature perspective, obviously, giant realm there. They had hundreds of thousands and millions of features that they were able to work with. And I want to look at three specific examples of the results, and there are many more, and just kind of dig into that. All right, so the first one is around what they call multi-step reasoning. And the prompt they put in was fact, the capital of the state containing Dallas. And obviously, you know, we're recording this here in Austin, Texas. The answer is, represent. The right answer is Austin. And what's interesting about this is there's a two-part process here. You have to understand first, what state is Dallas in? And then you can derive this. The answer is the capital is Austin. What they found was, it was actually doing a genuine two-step process in their interpretation. They wondered if it would just take a shortcut, if it would just had seen this answer so often in its training step, would it just highlight Austin, and that would be all of the sort of features that were activated. They found out actually no, that it was looking at, you know, capital and Dallas and state, and those activated different features. Capital and state activated what they call the say a capital feature.
Mm.
Okay. And then Dallas registered the state Texas. And they found that it didn't just jump to the output. And in fact, they could modulate it if they went in and they changed Dallas or left Dallas the same and then went in and suppressed Texas as a feature and highlighted California as a feature, it would actually say Sacramento. Okay, so it really truly was looking at leaning on these features. And it really suggests that it's occurring, at this sort of two-step process. Okay, I got another one for you. You guys buckle up.
Really interesting.
It really is. It really is. Okay, and the next one is they talked about planning poems, and I love this one. So they essentially gave it a prompt, and the prompt was he saw a carrot and had to grab it, and it was told to finish this poem. And grab it, carrot, where I'm immediately thinking rabbit probably. What they found was as they added each token to the input, it wasn't until it hit the new line token that it started thinking about its response. And immediately it started lighting up things like rabbit and habit and words that would rhyme. And once it had essentially done that, it almost did like a backtrace and started focusing on phrases and words that would match that couplet and allow it to fit in.
That's probably how we do it, right? I mean,
I genuinely think that's true. I've been thinking about this for about a week, and I'm thinking if I'm writing a poem, I'm probably thinking about what I want to rhyme, and then I'm reverse engineering how to get the number of syllables to work, right?
Yeah. I actually just recently wrote a collection of poems, and that's exactly how I went about it.
Okay, so that's exactly how he works.
Sort of, what are the key words? I want to make those the rhyming words so they really get emphasized, and then how do we fit that into the syllables that I have to work with?
Right. And this is really, really interesting. I mean, they found that it was that new line character. It didn't really start planning ahead until it saw that new line character, which makes a ton of sense. And then the last one, and there are really, really many, many things here, but there's too much to talk about. I want to talk about, this is maybe my favorite one. They wanted to understand how it did addition, right? A language model, of course, you would think, it's trained mostly on words. It wouldn't really be that good at addition. This is something really more for a calculator. But it had seen so many examples that, and by the way, all of this was done on Claude 3.5. I think Claude Haiku. So just, we're talking a substantial model here. On the addition, they found that it does all of these weird sort of like heuristics and shortcuts and lookup tables. And it's essentially memorized the right answer for all 1 digits, kind of like humans do. So those are just pure memorization. But once you get into double digits, it has all these heuristics about what's the remainder if you sum them together and other things like that. And they could trace it through pretty clearly and understand how it was doing it. But then when they asked it to explain how it was doing the addition, it had no knowledge, no concept of how it was actually doing it. And it just made up this complete fabrication that, the way you would normally do it, add up the ones column, carry over, add up the tens column, carry over. And that's really shocking because that's also very similar to the way our brains work. We will frequently sort of post hoc explain our thinking when we don't have the ability to introspect it. And there's a really famous experiment where there were some subjects who had their hemispheres, the 2 hemispheres of their brain separated, sometimes because of epilepsy. These are sort of discarded treatments, but from back in the day. And they would show to one eye only a video. And as your right eye's connected to your left hemisphere and your left eye is connected to your right hemisphere. And the part of the brain that would explain what was going on didn't see the video. But they the subjects were responding to the video and saying things, and they would ask them why. They didn't know why, and they would make up an excuse and completely believe the excuse, even though it had nothing to do with reality. So I think that this work is really important for a couple of reasons. One is only a company like Anthropic or a handful of these frontier labs operating really, really at scale are going to be able to do these deep, deep introspections. And I think and you guys push back on this. You push back on this. I feel like this pretty conclusively puts to rest this idea of sort of pure memorization, which you'll
stochastic
parrot. It really does feel like that is not plausible given the depth of this analysis. And then lastly, I think that it's interesting that we're moving from this phase where engineering, especially with AI, is now having to use scientific tools to go back and explain these things after the fact. It used to be that, we didn't really need to use the scientific method on the things that we built, right, to explain them. And I think that those days are over. Okay, so that was a lot, but I think it's a really, really important paper, and I think it's going to go down in the annals of model interpretability.
Yeah, really love this. I really like Chris Ola's work. I think this is one of them, and previously also the circuits. Trying to explain the model. Yeah, circuits and features. Yeah, I feel like this is a big step in terms of in explaining the black box large language models and how they work. But I think because the way they do it is that they don't do it on the model itself, right? They train a surrogate model.
That's right.
To kind of approximate the original kind of Claude 3.5, and then try to use the surrogate model to generate the behavior and study the reasoning, like the reasoning steps.
That's exactly right.
Yeah, but I totally think this is a very promising step. One quick question I have, Ron, is that I'm curious about. So let's say. For example, the state of capital, the capital of Texas question. It's a two-step reasoning. Does that reasoning happen sequentially? Like when the inference go through different layers, like maybe the first few layers do the first step, and then the second few layers do this.
Yes, that's exactly right. And so what they found was that. I'll give you an example that another example that's really interesting. They found that there were concepts that were independent of the language that it was going to output in. So this particular model, Claude Haiku 3.5, is fluent in over a dozen languages. And so they found that it had essentially a conceptual semantic representation for concepts that were closer to the middle layers of the model that were language independent. So if you asked it to do, I think the example was they were asking for the opposite of the word small. And they found that the representation of the word small in those middle layers were independent of what language the prompt input and outputs were. So if it was in English or French or Chinese, it still referenced that same feature representing small. And if they flipped those features and suppressed it, it worked across languages. So it really does seem like these models are thinking in a language agnostic way. And then translating that into specific languages towards the output layers of the model. That's a great question.
So that connects interestingly into some older models from linguistics of human language, where basically, even if you are monolingual and maybe even not that good at your language, the idea is that there's some sort of abstract representation, and then there's like the performance step where you need to take the abstract and make it into words. And that even sort of fluent people speaking to other fluent people that language is still just sort of an approximation of what you're trying to get to, and that there are potentially, this is a little bit probably older now, and maybe not quite so modern a theory, but, originally people were even investigating is there like an abstract form of every word, and we can never hear what that is because we have to speak it. And by the constraints of speech, it sort of gets transformed and comes out in some other way.
Right.
So this is, I'm not exactly sure where that line of thinking has gone in modern day linguistics, but it certainly fits very well with what we're talking about here.
Yeah. It also seems like if you can understand the way models think, then maybe you could also incentivize or regularize or control so that the type of thinking or behavior that you want to emerge is selected for.
Right.
And I know right now, it's basically just a black box. We can control a few things here and there, but we just stick in some stuff and see what comes out the other side.
No, you're absolutely right. One of the things they looked at were like hallucinations and jailbreaking, and they found, for example, like even if the model had been, trained and aligned not to, for example, tell you the recipe for how to make a bomb, that if they manipulated it in a way where it essentially started spelling out the word bomb, but they literally at like such low-level sort of features, I think is the way they describe it, where the individual letters were being focused on, like B, O, that by the time the model realized what it was actually outputting, its other behaviors took over. Its need to have grammatically correct, syntactically correct sentences, and its alignment behavior to try to please the user, that even though it's not supposed to tell you how to build a bomb, if they kind of forced it to in that beginning, it would then finish out and tell you how to build a bomb, even though it really, it only realized too late that that's what it was doing.
Yeah.
Fascinating.
So this, your question, Michael, ties to a question I wanted to ask about the poetry example. Which is to say, you say it kind of hangs on that new line, and that's sort of where things get set into motion. What would you all consider to be the features of a successful response to write me a poem? And then providing a line and a new line. And the reason I ask is, again, I think that what's so special about these models is the way that they're aimed towards usefulness, not correctness. And to me, what is a useful response to write me a poem certainly involves the rhyming, certainly involves these things. Like, I'm not surprised that these are things it has learned to emphasize, maybe at the detriment of other things, which is, I have an anecdote about that later on. Yeah. I'm curious if that lines up for y'all or if you think about it differently, but I don't know. It's impressive, but maybe not surprising to me.
Yeah, I think I agree. Like, if like I ask someone else or a student, like, to give me an answer, and if I wanted to see whether he or she really understands the problem, then I would expect, that the path to the solution should hit certain intermediate point. Take the correct path or steps to arrive at the destination. So I definitely feel like some evidence, either in the reasoning trace or in the features, that can show, these are the correct ways to get to the answer. I totally feel like that's that will make me feel more confident.
Yeah, that it maybe hadn't just memorized an answer or was regurgitating something it already knew about. Yeah, 100%.
Yeah, did you turn on the test set?
Exactly. All right, Michael, I'm going to throw it to you. What do you have for us?
I'm glad we started with that one. I have this love affair with Anthropic. They're just such a good, responsible company. And I feel like they're kind of them and OpenAI are sort of like the tortoise and the hare.
Yeah.
And I hope the way this story pans out is in their favor, like that one. But
yeah, big fan of Anthropic here too.
Yeah, but I'm going to give you an update on the hare anyway. So I'm gonna skip the GPT-4 image generation topic because I know someone else is going to cover that one here shortly. But I think just a couple really quick hitters about OpenAI and the stuff they've been up to. It's kind of obligatory at this point. So they have this academy that they just released, I think in the last week or two or so. It's really recent, and it even includes things like how to use LLMs for the elderly. They're clearly trying to broaden their target market just through education, things like that. So they're really stretching for, billion users or whatever their target is. That said, they're at 20 million paid subscribers now, and that's a 30% increase in the last 3 months. So they're still on an upward trajectory. They have 500 million weekly active users as the most recent report, I think, from The Information. And then apparently, with all this open source activity, they're planning on a new open source release, which would be the first one since GPT-4, which we were all excited about when that came out.
Yeah, and that was what, 2020, almost 5 years ago? Ages ago.
Yeah, to the point where it's obsolete.
Okay, that's great. Now, on that, I can't help but think that they would not be doing that if R1 hadn't come out in January, right?
Yeah,
Open source for the win, you know?
Yeah,
Let's
damn
keep
right.
this train rolling.
Damn
Competition.
right.
Yeah. But that just a couple little updates there.
Okay,
Nothing crazy.
that's great. All right, ZZ, what do you got?
So GPT-4 image.
Good.
As a communication guy, I'm super excited about it. I didn't have a high expectation, but when I tried it out, it's really just next generation. I want to talk about its quality. How it compared with the previous generation of models. I want to talk about the some speculations that people have about how it works, because although OpenAI released a technical report, I think it doesn't have too many details. They did mention it is autoregressive, but what I'm very curious about is whether diffusion is used at all.
Yeah.
I'm super passionate about diffusion. I'll feel a little sad if it's totally gone. But
Yeah, I was shocked when they said autoregression.
And I want to talk about some related papers to that. And so maybe let me first start with the quality. So I think what makes it really good is that, because of its, probably because it used like interleaved kind of text tokens and visual tokens, basically text image mixed together as input, and be able to understand the prompt really well to generate image. Maybe it's because of that. It has really good kind of instruction following. It will understand your input image, your prompt image really well, and your instruction really well. And it also has a pretty good text rendering quality that previous models didn't really capture.
Shockingly good.
Yeah. So I'm curious, what use cases have you seen? From my side, I've seen people doing a lot of stylization. The Ghibli photos. That's the most popular one. But that's not the only style. You can do Disney style. You can do 3D. People use it to do segmentation.
Yes.
It's not as accurate as a true segmentation model, but it will generate an image that has masks of persons, cars that look like us, like a segmentation output. But really, I think what's happening is that it's stylizing your photo into a segmentation style. Kind of. I think all these stylization really demonstrates the capability of instruction following.
Right.
I've seen people generate grid comics.
Yeah. Yeah.
So those comics with texts, accurate texts, and that's really.
I saw one just today that really impressed me. There was a photo of their bedroom, and they said, "Take all the furniture out." So did you see that one too?
Yeah.
That was mind blowing. And I think you hit upon this: the fact that it can take an existing photo and use that as a starting point. I think that's part of the reason this is so popular right now, and it caught the public's imagination, because you don't have to start from scratch. You don't have to walk in and be creative out of the gate. You can take a photo as a starting point, maybe a photo that is meaningful to you, and play with it. And that is a little bit more accessible for most people.
I actually tried playing around with that a little bit. We were just a few engineers and I were playing around with restyling some headshots yesterday, and it worked really well. We're like, hey, make a cartoon version, make a whatever, even use this reference image for brand styling and things like that. And the restyling part worked really well. But one thing I tried that it totally fell down on, that I tried multiple times, multiple ways, I just gave it a photo of myself and said, generate a professional headshot, and was trying to see how it would do. And then in every case, like, there's no way I could get it to generate an actual image of me afterward. It was all just some random.
I had the same experience.
Yeah, I think I saw someone else try that before. Like the identity consistency is not necessarily there, and it might even be intentional. But
that's a good point. Actually, that is the thing about this that seems at least the most concerning on the surface, is that the pace of improvement of these image generation models is far out exceeding our ability to understand and detect fake images, and it's got a lot of implications.
I'm glad that it came out right before April Fool's, because I think that will really sort of leave a clear, lasting mark that what you see may not be real.
Yeah.
I had a funny situation actually recently with some image generation that, in retrospect, isn't surprising at all. But I was doing some stuff for my Dungeons and Dragons game, and I needed a picture of a centaur. Turns out the models that I was trying to use, this was a few months ago, so it wasn't the current models, really, really did not like being asked to draw to create an image of someone with 6 limbs. They were hell-bent on sticking to 4 limbs and 10 fingers and 2 hooves, I guess, in this case. But it was very surprisingly hard to get it to generate something other than that. I think just because of how much they've been tuned to specifically try to get hands and limbs correct.
Yeah.
Well, just hitting 5 fingers was hell for 4 years.
Right. Right.
That's right.
So y'all think this is all just like safety guardrails in? I mean, it's not.
I don't know. It seems pretty real. It seems the text, I just don't know how you would even go about faking that.
Oh, yeah. No, I just mean like you think that these things that we're right now perceiving as limitations are more just protections that they put on the out.
Could be. It could be. I think as you push on one dimension, you may suffer in another. My intuitions were more along the lines that these were unintended consequences, less than overrides, because you can just do so much with these models now. But I could totally be wrong. And OpenAI is certainly not.
Well, they'll never tell us.
Yeah. So what do we know about how it works? You mentioned autoregressive. That really blows my mind, and you can literally see as the image is getting rendered. What's weird is it's not like they only start from the top down. You'll see the whole image, and it's a little blurry, and then it becomes less blurry from the top. That's sort of a different modality than we're used to. What do we know about it technically?
Yeah, that's a really great question. So a lot of people have tried it and shared it on Twitter. I also tried it on several images, and from my observation, it looks like the generation process, at least from the UI, from their UI, looks very different from the previous generation model in diffusion, where you would have a noisy image and then slightly better and then slightly more clear until you have a clean image.
Right.
But everything kind of changes in parallel. The whole image changes. But here, it's you can definitely see the scan line pretty clearly.
Mm-hmm.
People have discovered that's a UI trick.
Okay, that's what I was wondering.
Yeah.
Okay.
It's one and the same thing.
Yeah, so people are seeing, OpenAI backend would send back 5 photos for each generation, typically. But the UI will, try to render line by line. But, if you look at the 5 intermediate images, it's still autoregressive. It's still kind of, from top down, from left to right. It would generate the top part first and then go down, etc. So it's still autoregressive, but it's definitely not like line by line level of autoregressive.
Okay.
And there's a clear 8 by 8 patches kind of pattern.
Okay.
Got it.
I am so happy to hear that, because I don't know why my intuitions were, I think this might be a UI thing. It didn't make sense that it would actually work like that.
Yeah. And so OpenAI's team, I think, actually posted a photo. I don't know whether that photo is generated or it's a real photo. It's a photo of a whiteboard with a person writing on it. And if you look at the text on the whiteboard, it actually gives you a hint of what, the underlying architecture of this model. So basically it says, this model, what they wanted to build is a general framework that's a big transformer that is able to kind of model jointly the image, the text, the audio. Although, in this model, we know that we can't prompt with the audio yet, but maybe that's where they're going to. So they wanted to model this joint distribution. And I would imagine, that's an interleaved way. So the benefit would include better text rendering, and many others. And then they also mentioned that there are some drawbacks, and the solution might be that you want to have this autoregressive model to operate in a latent space. So imagine you have latent text tokens, visual tokens. That's your training corpus now, instead of just text. And then if you train a language model on top of that, an autoregressive language model on top of that, you'll be able to generate these latent tokens.
Okay.
Be it text or image or audio, maybe.
Okay,
then,
so real quickly, so the latent tokens that it's generating are sort of modality independent. Is that the case? Meaning because they're latent, it's not rendering them yet as an image or audio or whatever it may be, or is it something different than that?
Yeah, I would say they're probably unified. Maybe not as unified as into a common dictionary with the token ID, everything, but they are definitely unified to make it much easier to leverage the pre-trained, for example, GPT or Llama or other models, and bolt on the ability to also generate visual tokens. So yeah, autoregressive model on the latent space, and then a powerful kind of decoder. And they mentioned diffusion, which I really like. So maybe they use a diffusion decoder instead of the more kind of traditional deterministic VAE decoder.
Right.
Yeah. And yeah, happy to dive more into that. But that's, it's still speculation right now. I see a lot of people putting out hypotheses. But yeah, really hopeful that in the next few months, open source community begin to replicate.
Yeah, it will be really interesting if it's truly a bit of a novel architecture. May take a little bit of time, but I have full faith that open source will get on this quickly.
Yeah, and in the interest of time, I may maybe I can talk about the 2 papers later, and how about we keep going?
Okay, that sounds great.
Sure.
Reed.
Well, can I ask you one question about it?
Yeah,
before we
absolutely.
move on?
Love it.
That sort of architecture, if that is sort of what it's really working with, sounds like it has a lot of interesting avenues for personalization too.
Yeah,
it seems like you could take just one particular type of encoding slice or decoding slice and sort of tune that to a person quickly. I guess this is the second time now I've asked a question that was just a sentence, but yeah.
I think people are trying out different kind of combination of, hey, can I take this pre-trained like Llama and then I'll bolt on a diffusion, a stable diffusion model and fine tune it to basically, and maybe I can add a vision head into the Llama.
Right.
Yeah.
Right.
And then bolt on it, and then you can switch out the diffusion model into another kind of decoder.
Right.
You can switch out the autoregressive into something maybe not autoregressive. There's a paper about it. You can actually do bidirectional kind of attention, so that when you generate your image, when you're at the bottom part of it, hey, maybe I should go back and change that part change the top part of the image. Actually, this I think this happened for 4.0 too, 4.0 like GPT-4 image generation, because when you see the intermediate result, it doesn't look like once the top part is finished, it's done.
Right.
Like they still change that, although very slightly.
They do, and that's one of the reasons I thought the UI might just have been a little bit of a parlor trick there.
Okay.
And the only other thing I wanted to add about this, that there are rumors also, and I think partly it's based on some of the things that OpenAI has said, is that they don't take the raw input prompt alone and then just immediately put that in the model. My understanding is it actually goes through a language model, which then refines the prompt in a way that makes the image output even better. And I think that is a very sort of simple but clever approach to make sure that, even novice users get, strong output.
I think that's been a relatively standard feature for image generation for a little while now, because most of the different tools I've seen at least will have like a refine my prompt or improve my prompt sort of checkbox.
Right. Exactly. All right, Reed, we're throwing to you.
Yeah. So a little poll, I think, for the room. And I already talked to Zizi about this because I was really excited about it. So your vote doesn't count. Zizi.
Michael, you and I don't know about this. All right.
So
fresh eyes.
I was doing some creative work outside of work, and I was running some analogy. I was getting other opinions on analogies. So the analogy that I asked ChatGPT about was, let me make sure I get the phrasing exactly right. Dread is to what as winter is to summer.
Dread is to what as winter is to summer. My mind would probably go joy, something like that.
Excited anticipation, and something like that.
So what GPT said was
longing. That's good.
Hope is to dread as winter is to summer.
All right,
that's good.
That's good.
Yeah. The only problem is it flipped the analogy on me, which I didn't realize until maybe the fourth one that I was running through.
I don't know what it say.
So I said, dread is to what as winter is to summer? And it said, hope is to dread as winter is to summer.
Totally flipped.
It totally flipped half of it.
Interesting.
And I didn't know that. I did 4 or 5 of these, and it was maybe the 4th one where I was like, hold on a second.
That's funny.
That isn't right. Like, it got me what I needed, but that's not actually right. And I've been noticing also just in general that these systems tend to, they'll still give you a very wordy answer, but they tend to be very direct right at the beginning and very directly say, okay, here's what you wanted, or the answer is this, and then a big explanation. And so I've been wondering if the drive towards a quick, actionable answer is, in this case, overriding the importance of the structure of the analogy. But just a funny little...
Well, there's a financial incentive to do that, too. Just keep the output short and sweet.
Yeah.
At least you can.
And the fact that I barely even noticed that it flipped it at first,
Yeah,
because you know exactly what you're listening for.
Yeah, exactly.
And reasoning, I would love to see the reasoning trace if it's available.
Oh, yeah. Yeah. Absolutely. Well, yeah, we need to get them on.
Get Anthropic on the case.
Yeah, exactly.
Maybe I should have asked.
Let's give Dario a call, see if he can here.
We'll give him a ring. All right. I have to bring up the delay with Apple Intelligence, right? That really kind of, we've all been waiting on since they announced it last June. And I'm going to get on my soapbox for just a minute. Okay. You guys ready? Okay. I've been saying for years that as powerful as generative AI is, people need to be really, really careful about trying to hook it up into circumstances where there is not a human in the loop. It's where it's doing things just directly interfaced with an API or a device or some type of, physical object in the real world. And the reason is that as powerful as these generative models are, they still have sort of like an infinitely fractal, edge set of cases where they fail. And it's really, really hard to make them bulletproof. And the word on the street is that what happened with Apple was, they couldn't fix the issue with these edge cases. And it included things like people being able to send you an email and that would trigger behavior on your own device, that you didn't even know about, and it might perform actions, right? And what's really interesting about this to me is for Apple to, incredibly smart people there and really, really high executing company, but this is new for them. This is not traditional software. This is what we tell our clients all the time. You can't run into these types of issues and say, all right, well, we'll just pull an all-nighter, or let's just have the engineering team work really hard for a week or two and we'll make the model stop hallucinating, or we'll knock out all these edge cases. It just doesn't work like that with these probabilistic models. And so this is going to be my go-to story, my go-to cautionary story for all prospective and existing clients about the dangers of generative AI without a human in the loop, given the state of technology we have right now.
Yeah, especially with agentic stuff too. I mean, this is
that
is everyone's so excited about having agents and everything that they do, but there's so much.
What could possibly go wrong, right?
Sure. Or the frontier beyond that, where there's like an orchestrator that subscribes to 12 agents made by 12 other people that you can just hook up to.
Sounds super safe.
Oh, yeah.
Honestly, if I was in cybersecurity right now, I would be paying very close attention because there's a lot of opportunity there.
That's exactly right. That's right. All right, Michael, I'm throwing to you.
All right, this one's a little bit meatier than the last one, so bear with me here. But it's definitely on theme. There's some common thread across this. So this is a paper that I don't think is getting nearly enough love. Like, you can look on Twitter, people have talked about it on Hacker News. There's some summaries online, but it's really not blowing up. And it's about, the latest update, I think, is about 6 weeks old. So it could be that it's just super fresh. But the paper's called Scaling Up Test Time Compute with Latent Reasoning. And pretty self-explanatory there. Instead of taking, right now, all of the reasoning that we typically talk about with modern language models kind of happens in the output space, or at least the model is externalizing this reasoning. But this is distinct from that because that reasoning is happening in this embedded space,
right,
rather than the output space. So since chain of thought is a little hacky, it's maybe not exactly how we think about this as humans. That counterexample you brought up a second ago with the split brain experiment, that's got my wheels turning here. But when I read this, I was thinking, I read that exact example from Anthropic where the way the model describes doing math is fundamentally different than how it says it's doing math. And this is a way for you to just keep all that reasoning in latent space. So, and another really important piece before I jump into the approach is that the amount of computation it should require based on a certain input token length should be highly variable. It kind of stands to reason. Like, if you say, the opposite of dread is hope, answer, that could be a lookup table, very simple, not really any multi-hop reasoning. But when you start getting into things like familial relations, like, Greg's dad is Bob, Bob's dad is Tom, who's Greg's grandfather, the amount of computational depth you need for that is just a little bit different.
Well, and I would add really briefly, this is my go-to on this, is that, there are some things where the answer is it's either black or white, or you know it or you don't. No amount of reasoning. If I ask you, what day somebody was born, you either know or you don't know. You can't reason about it indefinitely and improve your answer.
Yeah, that is such a perfect tee up here. So unfortunately, this is an academic lab. This is the PI's name's Jonas Geiping, and he's at the Max Planck Institute in Tübingen. So he and his ragtag team of academic researchers kind of got together. They pitched this idea, and they actually ran it on AMD hardware at Oak Ridge. And they were sort of just running it whenever they could continue their experiment. It happened over the course of a month or so. But they took a 3.5 billion parameter model, and they trained it on about 800 billion tokens. And because this is kind of like a reasoning sort of model that they're trying to train, they hand selected this data set to skew more toward math and coding. Kind of stands to reason there. The architectural details, I guess we don't have to get super into those, but one thing I thought that was interesting is that much like skip connections in visual models, like, y'all definitely familiar with that, they found that to have convergence in this model, it was important to include embeddings in those recurrent steps. And by recurrent steps, I guess I buried the lead there. So it's a super simple idea. There are 3 parts to it. All of it's decoder only. There's this thing called the prelude that they call it. It's a very musical analogy. You just encode the input sequence. And then in that middle piece is a recurrent model that can arbitrarily choose how many steps it takes to complete the reasoning. Okay. And then it'll put it in what's called the coda. That's their term, but it's just the output decoder. How do they do that? Great question.
Wait, hold on. What's the second part? Is it rondo or?
That's a great question. They actually just said, I think they just call it recurrent block. I think they missed an opportunity.
Yeah, missed opportunity.
I'm sure they could turn that into an acronym as well. Rondo is already part of the way there.
Yep, that's true. That was great, Susie. But yeah, basically what they're doing is when they train, instead of just allowing the model to recurse arbitrarily until it gets the right answer, they'll sample the amount of reasoning steps from a Poisson distribution, where the average is 32 recurrent steps. And they played around a little bit to hand tune that. And then they'll just give it all the prompts. And sometimes it would use all the reasoning budget that it had. Sometimes it would converge early and just sort of stabilize to finish. But then what they found is by training in that way that's very predictable and fixed and stable, once inference time happens, you monitor that recurrent space to see how the embedding converges. And if it satisfies these convergence criteria, then you pop out and decode it.
Okay.
Does that all make sense?
I think so.
Yeah.
Okay, I definitely have some questions. On the recurrent space, and you're saying they're looking for it to converge. Do you what does that mean? What is converging there?
That's a great question. So they have a few really cool visuals in the paper. I can find them and we can pop them up on the screen later. But convergence sometimes just means to a point. Like if they show some embedded representations that they just do PCA on so that you can look at a couple components at a time. And you watch it throughout the recursive steps. You'll see it kind of bounce around in latent space and then it'll converge to a point. And the difference from one step to the next is basically nothing.
Okay.
But they also found that sometimes it converges to things like orbits, which they also have visualizations of. So
wow.
I don't know exactly what that implies in terms of how the reasoning's happening, but the visuals are really striking, and it's really thought-provoking to just think about convergence being orbits.
That really is interesting. I think as we've moved towards these reasoning models, I've talked to so many people where everybody's kind of almost independently come up with this idea of trying to stay in the latent space as much as possible, right?
And there's a common theme for sure.
It's definitely a common theme, and to try to have convergence there makes a ton of sense. And the idea that the model itself could determine when it's done, and essentially, now we're getting into energy minimization and all these other things that there are other research labs out there that think that that's a really important component. You can go far afield as like active inference, where you're talking about energy minimization being a big component of intelligent systems.
Yep. Yeah, definitely some overlap there. And it's unfortunate. I just want to sort of promote Jonas and his team here because they're doing a really interesting research on a shoestring budget. If they had the resources of some of these hyperscalers, I think the outcome would be totally different. They really just need to go beat this thing into submission and figure out what's underneath. But the big takeaway there is that they're punching above their weight in terms of model size. So it's a 3.5 billion parameter model, and they compared it to Olmo and Pythia. And as a simple takeaway, it generally performs as well as a 7 billion parameter model with similar training and input data. But it's not really an apples to apples comparison. I think there's just so much left to uncover. It's a really interesting research direction, and I'm definitely going to be following Jonas's lab.
Way to go, Jonas.
Yeah.
For sure.
Awesome.
Yep. I'm really curious to hear about the synthetic data topic that Rick's going to talk about.
Yeah, absolutely. I know there is such a thing as time. I also have questions for Jonas, but we'll go into the synthetic thing. So about 2 weeks ago, I think, there was a lot of news that came out about Nvidia buying this group Gretel AI for their synthetic data generation capabilities. And I think it's like a 9-figure deal. So hundreds of millions, right?
Yeah.
I did not get an exact number. I don't feel like it matters that much to me personally. But once we know we're in that range, that's all the information I need. So I did some reading about Gretel and who they are, what they do. And originally, the first thing or at least the thing I did a deep dive on, I found a white paper of theirs from 2021 talking about Gretel AI as a system for generating synthetic data in situations like a medical context where there's a lot of PHI involved. So if you just synthesize all of it, then suddenly your data handling gets a lot easier. And in the specific case that they were looking at, which is sort of like behavioral measurements of toddlers who might be autistic or have autism. I don't know if there's a better way to say one of those two. It's just hard data to gather. So if you could synthesize a lot of it, you might be able to more quickly generate models or do something to help or understand or diagnose, whatever the case may be. In that paper, as best as I can tell back then, they are looking at basically taking a small sample and then generating more text that matches distributions in feature space and matches distributions in sort of PCA space. I assume they're keeping the first the PCA transformation from the first data set. Otherwise, I don't know how you would end up with the same rotation.
Right.
But, or decomposition, I guess. So it seemed interesting. That's an interesting thing. And it kind of got me thinking about synthetic data in general, because in my experience in NLP, synthetic data has almost always fallen flat. I really feel like it very, very frequently misses the mark on making something realistic enough to be helpful, though most of my experience in that is from before LLMs. But then if you trace it back to sort of the computer vision world, and if you want to consider, clipping or rotating or flipping as a form of synthetic data generation, it's like crucial.
It is
Absolutely necessary to build a good model.
There was a project, I want to say, where we tried some augmentation techniques. Like there's a library for language augmentation. I remember it just being totally underwhelming.
Yes. Yeah. And then thirdly, something Zizi brought to my attention a while ago is Google's Genie project. And Genie 2, which is sort of this, a system so that you can configure a world that you can then run to generate data to train maybe a reinforcement agent on or something like that. So it's just sort of a lot of gears turning about if what practical information people should know when it comes to synthetic data in our sort of new heavily generative AI world where everything we've been talking about you could call synthetic data from this conversation. So I had a couple thoughts that I wanted to pressure test.
Lay it on us.
First question, if we have such powerful models that they can generate excellent synthetic data, why do we need the synthetic data?
Oh, you mean like, can we just train from the...
Can we just use the model
latent
for the
embedding?
task? Yeah.
Oh, interesting.
Well, I assume there's some downstream goal, right?
I mean, surely.
There's got to be, right? That the synthetic data is augmenting some data set that is just a step in the process.
Yes. Mm-hmm. So that's where I went as well. And I try to think about what those might be. I have 4 things. What are the reasons you'd need, what are the reasons you need any data set right now, really, as opposed to just an off-the-shelf model, right? Well, one is if you have a model, even if it's an off-the-shelf model, you need to evaluate if it's good or not. Whether it's a model, an algorithm, whatever, it doesn't need to be AI at all, right? You still need data to evaluate. And you're going to be able to iterate a lot faster if you have a data set on hand rather than just putting it out into the world and measuring as it goes.
Yeah.
Right.
So evaluation is one thing. Training to a more specific task. So there isn't a model for this yet. Right. We need a data set to create something more specialized. I haven't heard about MedPalm in a little while, but I still have very high hopes for it. Third, maybe you have private, very differentiated data. Maybe you're trying to build a competitive advantage around specific data but you don't have a lot of it, right? It's hard to get to. You want to expand that asset. Or you want to build a better foundation model, which is, I guess, to the 45 people who might be doing that, probably already have your own ideas.
Right. Well, all right. On some of those ideas, I mean, I love this because this is getting the wheels of my mind going. Just some thoughts. On the medical side, it makes a lot of sense that you would do something where you would say, look, the distribution of this data matters, not the specifics of any piece of data within it, right? Meaning, you want the shape, the general shape, but you don't really care about the details for privacy reasons, right? So I could see that. I could see that being a very, very common one. But then, it begs the question, like, I think a lot when I think about AI and I think about intelligence, there's this component of compression that comes up a lot, right? This idea.
I'm right there with you.
Yeah. Okay. There's this idea that intelligence is a way to, it's more than just making connections and having insights. It's a way to compress concepts. And we know for a fact this is what's happening within language models, is that you're moving along some sort of very high dimensional manifold and talk about everything coming full circle, reasoning in the latent space and everything like that. And so to me, focus on the synthetic data is in a weird way akin to trying to understand at a better and deeper level that element of compression, which is tied to intelligence. And that's really just nothing more than just sort of a broad thought there. And the last thing I'll say on that is, and I want your opinion on this, Reed, there was fear, I think, a couple of years ago, and you don't really hear about it a lot. Maybe it was even last year, about AI's taken over the internet, and and AI's trained on the internet, and so now the AI is going to be trained on its own output, and then it's going to be this homogenization. Everything just averages out to a medium blur.
There's a blog post right now where Stack Overflow is the thing everyone's focused on right now, just because like all this code generation, all this code assistant stuff we have, it's trained on Stack Overflow, but no one's using it anymore, and it's taking time bombs, right? Yeah, exactly.
Yeah, exactly. All right, and what's your reaction on that? Like obviously, Gretel did something very interesting, very valuable. How are they avoiding this whole just average out to nothing? Do you know any details about anything that they may have done special?
I don't know too much, given, the main thing I dug into was the white paper from a few years ago, but it looks like they've really, really grown since that happened, just based on the vibe of the paper. But I think their whole thing, from as best as I could tell, is really take something that is unique and special and sort of grow or emphasize that. Not like just generate 40 more petabytes of whatever to shove into a language model.
Right.
Yeah.
So I think that their mission's probably pretty considerably different.
I'm almost wondering if it's helpful to think about other domains too, where something like radar, where you have extremely compressed understanding that's not readily available to something like a deep neural network or whatever you're working with. Like if you have a millimeter wave radar sense and you have these analytical closed form expressions that describe scenes, that's not something that you can immediately go train a model on or something. It's just too compressed. But if you go through the synthetic data generation process, like, yes, I guess you understood the domain to begin with, but the data itself wasn't in a form that would be amenable to training a model.
Oh, that does make sense.
What I mean?
Yeah, no, that makes complete sense.
Yeah.
Okay.
Yeah. I do think there's an aspect of Project ZZ that you and I worked on together where we were trying to make sure that, yes, the model works generally, but does it also work for specific slices of underrepresented people or specific different, classes of data, subclasses of data, or whatever it is. And we just didn't have enough examples to be able to really score it. While it's not ideal maybe to just synthesize more of that and call it a day, it's certainly better than not knowing at all.
Right.
So I do think maybe there could be, I see what Gretel's saying around sort of like some of this data is just really hard to get. And if we could just have a little more of it with some minor variations. Again, it took me back to image augmentation.
Yeah.
We didn't make new images out of nothing. We just flipped a couple of them, and it turns out that's really helpful.
Yeah. Yeah. I think, for example, if we want to train our self-driving car about dangerous situations, it's not really ethical to collect the real data about it, but rather to synthesize it. That's as long as it's highly plausible. So that brings to, how to improve the quality of your data synthesizer.
All right. I hate to do this, but we've got to wrap this up. We're almost at an hour, and there are tons more we could chat about, guys, but we're out of time. Thank you, as usual. This was so much fun. I really appreciate it.
Thanks for having us.
Yeah, thanks so
much fun.
Thank you for listening to Hidden Layers. This series is hosted by Kung Fu AI, a management consulting and engineering firm focused exclusively on artificial intelligence. If you have any questions or thoughts about today's episode, or if you know someone we should feature, please visit us at kungfu.ai.